Assalamualaikum. Good morning.
Assalamualaikum. Good morning. Boleh dengar?
Waalaikumsalam.
Okay. Today presentation day, mock presentation day, real one pada 20 apa? 29, 30.
30 Isnin.
Okay, jadinya ada 2 kali mock presentation lah. 21 dan 28. Okay, mock presentation sebelum final exam. Saya tak dapat pergi Penang, kita online je. Dah banyak kali kita online. Tiket terlalu mahal. Lepas tu Asia ni pula suka tukar jadual. Ikut suka dia je tukar. Ramai orang komplain Jadi menteri pun dah masuk campur tangan. Jadi tengoklah apa yang berlaku. Ramai orang komplain tak ikut jadual seperti yang ditetapkan. Menunggu satu hal, delay lagi satu hal. Okay. So without any further ado, I invite Saudara Sobri sebab dia yang pertama kali masuk. Orang yang pertama masuk dalam Zoom. Kita jemput Sobri untuk membentangkan.
Okay, bro.
Yang lain dengar.
Okay, Assalamualaikum dan selamat pagi. Bro, dengar bro? Okay.
Dengar.
Okay, ini adalah final year report 2 SKE 4824 dengan tajuk Integrated Electrical System for Reduction Energy Strategy Based Home Automation System. Okay, introduction. Integrated Smart Home Challenge to improve the future smart electrical system. Second, Internet of Things, IoT, to become a revolutionary in transforming many areas in modern living. Maksudnya sekarang kita menuju ke IoT, walaupun sekarang banyak tempat-tempat yang baru nak start to implement IoT based on seperti solar system. Sekarang banyak tempat dah menuju ke solar system dan kita tak mustahil kita akan menuju ke era IoT. Okay, yang ketiga itu energy saving management. Okay, dalam kehidupan seharian kita kena menitik beratkan energy saving management dalam apa jua di rumah, di pejabat atau di mana area pun kita kena menerapkan energy saving system lah. Okay, problem statement, waste of electrical energy. Ya, banyak berlaku di rumah kita sendiri berlaku wastage of electrical energy. Boleh jadi tidak ada kesedaran dan kita akan create awareness, kesedaran di mana belajar dan mendapatkan informasi bagaimana untuk create awareness. Dan ketiga, increasing electricity bill. Problem kita adalah bil elektrik yang tinggi. Okay, yang keempat, objektif to design the final circuit can be connected to a PIR, passive infrared motion sensor. Second, to apply the blink application and not MCU ESP32 control based on IT system. And tiga, verify the functionality of the system and monitor the electricity consumption. Okay, project scope. Okay, energy saver. Using the motion sensor, IoT, blink application, remote control, smart meter, Arduino IDE, C++ programming, and not MCU, ESP32, and last relay module lah. Okay, this is my project plan. Okay, simple electrical schematic need to be upgrade. Kita akan upgrade lighting circuit di area keseluruhan rumah lah. Okay, project scope and limitation is a important thing to design electrical installation. Okay, firstly source, knowledge, the type of load, calculation of the total load connected TCL and maximum demand MD, diversity factor, component and distribution board, and phase balancing. Okay, all need to determine circuit, breaker, size cable, and electricity supply from TMB. Okay, project scope and limitation second. Okay, electrical scope definition to kena refer term electric, uniform building bay law MS 1184, electrical system design installation, electrical supply application standard MS, ICE, BS, EN. Okay, electrical installation of building and JKR certification lah, LS1 to LS20. Okay, this is a calculation, the TCL and MD calculation. Sample of that. Okay, based on saya punya planning, okay, di sini saya dah letakkan bilangan lampu di kawasan living room, bedroom 2, bedroom 3, bath, kitchen and living room. Electricity preview 1, 2, 6.
6. Okay. Okay.
Methodology, project flowchart, start, define type of research, obtain sufficient information, digital review, okay, methodology, decision, if no, return to methodology, if yes, analysis and comparison, result achieved, implementation, discussion, conclusion, recommendation of the future work, and obtain.
Decision tu apa? Apa decision ni?
Decision,
Apa decision itu? Yes, no, apa benda yang nak disemak, nak dicek, nak dipastikan, apa decisionnya? Define tak? Nanti ada orang tanya. Apa decisionnya? Decision ni general, umumnya. Yang spesifik pada awak punya projek ni apa?
saving energy lah, saving energy.
Save energy or not?
Yes.
Save energy, okay. Kena buatlah decision.
Okay,
Nak buang decision tu, save energy, tanda soal. Save energy, tanda soal.
Tak Prof, nak masuk.
Nanti hang, Allah, mana dia pergi?
Gangguan. Energy.
Save energy, tanda soal. Decision tu buang. Okay, terus.
Okay, methodology. Okay, first motion detect. Okay, lighting control, and then power monitoring and record. Okay, preliminary result. This is a new sample layout yang takkan di kena planning di mana kita nak tentukan control by PIL motion sensor and not MCU and remote. Okay, this C1 control by L1, C1 control C3, C4, C6 kitchen area, install the PIL sensor. Okay, motion detect, maximum motion distance is 8 meter. If ada orang lalu, and then they can detect on, and then 6 per second, they can off. Jika orang tak lah, and then they control by no MCU, control lampu dan kipas. And then flowchart for bring application. Okay, pin 1 to 8, the control pin. PCB board, developer, support diagram for 8 resolution. Support developer. The process of acid emission drilling hole must be done by carefully. When the drilling complete, next step you will insert the returning part and jumper. Do the soldering perfectly. Okay, ESP32 control relay IoT application. Program the ESP32 with Arduino IDE C++. Controlling application for the bring application and remote control to the second controller. For safety situation to the Wi-Fi connected in the remote control is on in the application. Lampu function started. Arduino software.
Okay, Sobri, three main component of IoT, sensor device ada, connectivity ada, data processing ada, user interface ada.
Ada. Interface.
Semua ada Dia ada tiga komponen penting semua ada IoT tu ada.
Yeah. Okay, ada testing sensor detected. One the relay one circuit work. Integration at the DB board. Okay, instruction the PR sensor integration at kitchen area and bathroom.
Okay, tengok data result.
Okay, monitoring. Maybe meter reader for energy use monitoring before installation.
10.8. Naik turun. 10,000 kilowatt, 30,000. 10, 13, 12, 10. Apa orang nak cakap dalam ni?
Okay. Bill of day monitor untuk 30 hari satu bulan. Starting at 17 bulan 11 hingga 17 bulan 12 satu bulan. Then trigger to 24 jam lah. 24 jam energy use. And then this record from meter read kilowatt per hour. And then roughly 4.5 and 5 kilowatt per hour using at 35 hour lah, 12 jam lah penggunaan. Okay, this can be meter reader and energy use monitor before installation. Okay, lepas itu monitoring yang kedua after installation, starting tadi end of 17/12 dan starting 18/12. Day 1 ada penurunan 67. And then total energy use 195 untuk bulan ni. Ada penurunan.
Boleh you plot biru dengan hijau tu sekali dalam satu plot.
Combine sekali.
Lepas slide 34 tu.
Okay.
Jadi nampaklah yang hijau tu turun berbanding dengan yang biru. Faham tak?
Okay.
Mula-mula tunjuk yang biru. Tunjuk yang biru. Okay, ini adalah sebelum installation. Lepas tu selepas installation dapat macam ni. Dan bila kita compare slide 35, dia tunjukkan biru dengan hijau. Jadi awak akan dapati yang hijau tu turun daripada yang biru. Itulah awak punya findings. Sobri.
Okay.
Data ni nak collect sampai 29 lah.
Saya nak cabut lah sebab kita nak bawa pergi ke Johor.
Bila tarikh nak cabut?
Saya rasa saya nak cabut dah ni lah. 2-3 hari saya cabut.
Apa pasal cepat sangat?
Nanti nak buat lagi apa? Buat lagi nak install DB lagi.
Nak bawa benda tu? Okay. Jadi ni benda data ni berapa hari punya data?
Yang ni sebulan lah.
Sebulan. 31 hari lah.
Tapi takut. Saya takut SPT tu bakar lah.
Okay. Jadi sebulan. Jadi tunjukkan slide 35 lah.
35 conclusion.
Dah ambil data sampai awak cabut.
Okay.
Terus next.
Conclusion. Okay, result from FOB project based on test result. PIR sensor akan
Jap,
di
jap, jap. Jap. Awak punya objektif apa? Tengok objektif. Okay, design hardware to apply Blink application. Ni software. Nombor 3 to verify sama ada dia save energy or not. Jadi awak bincangkanlah nombor 1, nombor 2, nombor 3.
Okay. Saya combine.
Achievement.
Saya combine kan ni. Tapi memang dalam.
Nak buat 3 point pun tak apa.
Okay.
Jadi awak bincang achievement ini macam awak cerita, tak tahulah awak melalut cerita apa, saya pun tak tahu. Biasanya conclusion adalah membincangkan objektif achievement, pencapaian. Kan?
Okay, bro. Okay.
Jadi conclusion and then findings. Lepas conclusion tu findings. Findings maknanya awak proof method awak tu telah save energy berapa persen setelah awak bandingkan biru dengan hijau tu.
Okay, bro. Okay.
Okay. Betulkan lah.
Okay.
References.
Conclusion.
Lepas conclusion, findings. Lepas findings.
Ini
tak payah.
Tak payah?
Sebenarnya tak payah.
Okay.
Itu letak dekat lepas findingnya, awak letak je lah. Tak payah bincang pun tak apa.
Finding ya? Okay. Prof nak video, video.
Sekejap. References. Sebab dia ada markah dalam rubrik tu untuk references. Lagi. Tu je. Ada lagi 20.
4, 30.
Okay. Alright. Apa dia? Video. Okay, video.
Video kena tutup yang ni. Tutup dulu lah.
Tutup lah. Unshare dulu.
Prof mana pergi? Share. Ada muzik pula. Tak sempat nak. Nanti buat muzik sikit.
Berapa minit?
Ya, sensor. And then living. Nak tambah bilik.
Pakai handphone
Handphone IoT.
Pakai apa? Android ke pakai OS?
Blink.
Bukan, telefon tu Android ke?
Android.
Android. Software dia Blink, handphone dia Android. Blink tu memang free
Saya beli yang crack lah, Prof. Crack. Kalau yang ni.
Alright. Okay. Video tu boleh bagi cantik sikit lah. Macam budak sekolah je kau punya video tu.
Ni yang free punya nanti nak kena beli juga kat Shopee.
Bukan video kau ni. Video tu tak, kalau ada wording tulis kat situ okey lah. Tak payah cakap kan ada wording.
Ada.
Kenapa? Nanti kita tengok hari Sabtu depan.
Okay.
Edit dulu. Okay.
Bang.
Alright. So kita jemput seterusnya Zulfahmi. Orang yang kedua masuk.
Prof. Hello.
Ah.
Can you hear me?
Tan nombor 3.
I punya laptop macam ada masalah sikit tentang Microsoft. So boleh I restart PC sekejap.
Keluar dulu. Okay.
Okay.
Dulu. Okay.
Okay.
Zul. Berawal Zul. yang dah present, lajulah. Yang keputusan lama sikit. Silakan.
Assalamualaikum and very good morning
Salam.
to Prof and all the presenter. For today, I would like to present my final year project 2, SKE 4824, diesel generator control system integration with IoT. My name is Muhammad Azhar Fahmi bin Muhammad Badaruddin. So for introduction, in today's civilization, one of the most significant source of energy is the electric energy that generated by diesel generator. The difficulty and expense of on-site operation and maintenance provide certain challenge for practical production. The appeal of using smartphone to operate a diesel generator is that is increase safety and lower workers' dangers. Eliminate unwanted downtime. Customer will want to make sure that their sensitive information is still accessible and secure during an outage. Handlers high power load. Generator come in a wide variety of size and power capabilities, and every business will have unique needs. Maintenance, machine under maintenance, avoid costly outage with maintenance. It's important to keep it maintained to help avoid an unexpected shutdown. For motivational, it's include two elements. The first one is safety issues, lead to a fire or even an explosion. A long period of overheating can cause the equipment to catch fire. Continuous diesel generator monitoring, CDGM, increase the lifespan of generator. When the generator operate above capacity or start to turn hot, it will burn out the alternator and other generator parts. For the problem statement, the first is take a long time for regular diesel generator monitoring due non-continuous. The second one is technical personnel has no up-to-date information. And the third one is during office hour monitoring as usual. After office hour, monitoring using IoT therefore is work reduce overcome claim liabilities. The objective is to design a diesel generator monitoring system and develop the control circuit. Number 2 is to apply sensors, which is pressure sensor, temperature sensor, proximity sensor, voltage sensor, user interface and software in project development process. And number 3, to test the feasibility and consistency of the developed system. This is a project scope include with programmable logic controller, not MCU ESP32 as communication module, water temperature sensor, oil pressure sensor, proximity sensor, battery voltage sensor, IDE software, CX programmer, and not RAD. Project limitation. For the project limitation, measurement variable for low oil pressure, pressure maximum 100 kPa, minimum pressure 0 kPa, pressure maximum than 100 kPa project in kPa not in project scope. For the high water temperature, the maximum temperature is 98 degrees. The minimum temperature is 0. Temperature maximum than 98 degrees Celsius not in project scope. For the battery voltage, the maximum voltage is 33 volts. The minimum voltage is 23 volts. Battery maximum than 33 volts DC not in project scope. For the engine's overspeed, the overspeed maximum is 1710 revolution per minute. For the underspeed minimum is 1200 revolution per minute. Speed maximum than 1710 revolution per minute, not in project scopes. This is a literature review. I have include 6 literature reviews. This is a summary of a literature review. This is a methodology. This is a project scope. This is a project flow chart. We start with identify problem statement, then data information collection and literature. Next, identify component for hardware, electrical circuit design for decision, electrical circuit testing for on or off of the generator. Next, ladder diagram design. For decision is ladder diagram program working, yes or not. Next, Internet of Things interface design. For the decision is Internet of Things communication interface working, yes or not. Next, install electrical circuit and sensors at generator system. Then project commissioning and test run. This is a system flow chart. For this system, we start with sensor in a normal condition. Before that, I have include 2 system flow chart, which is offline operation and online operation. For the offline operation, we start with sensor in normal condition, then no sensor detect, diesel generator in normal condition. Okay, for the decision, one of the sensor detached, the system will reset and restart the generator. If not, diesel generator normal start. For the online operation, the system will start with modem initialization, then check low oil pressure, yes or not. If not, send notification about current status to smartphone. Repair performed by authorized person. Then system reset and restart the generator. For the check high water temperature, it same with the check low oil pressure. Send notification about current status to smartphone. Repair performed by authorized person and system reset and restart the generator. For the sensor battery voltage and engine speed, the process will be same. This is a experimental setup. We have a diesel generator unit. For the offline operation, diesel generator can start at the panel control beside the generator system. For the online operation, the generator system will be start with the smartphone. This is a existing circuit diagram.
Complicated juga
Ah,
Canggih genset ni je sikit apalah dia dah daripada supplier punya tu kan.
manufacturer.
Manufacturer.
This is a drawing circuit for communication module.
Tanya lah dekat sebelum PLC tu ada sikit apa tu? Yang
Tepi ni.
macam switch tu. RL1, 2, 3, 4, 5.
This is a relay.
Tahu function dia. Zul.
Relay connect to the PLC.
Tahu. Dia punya function. Relay function.
Relay function which every relay connect from the output of the communication module. Then
switch,
switch, yes, a switch. Okay, this is a communication module circuit board. Printed circuit board schematic design using easy IDA. The printed circuit board schematic development and finished PCB board. This is a not MCU ESP32. This is a relay. This is a connector for input, and this is a connector for output.
Ini awak buat sendiri?
Yang ni sedesign yang ni.
Buat sendirilah.
Board ni kena tempah.
Oh, kena tempah. Easy either.
Dan kalau yang iChing tu dia ni macam tu lah yang macam
Jadi bukan SMT bukan Surface Mount Technology.
SMT.
SMT. Okay.
Dia ada banyak layer kan. Okay, this is a component assembly connection between communication module or IoT circuit to PLC as a controller for the generator. Okay, this is Internet of Things structure. We have a water temperature sensor, we have low oil pressure sensor, we have a proximity sensor, we have a battery voltage sensor. All the sensors will connect the controller. Then the controller will communicate using Wi-Fi. Then all the sensors collect the data. Then the data will be saved in the Node-RED platform.
Okay, kalau tengok sini 3 IoT komponen ada
Ni sensors.
Sensor device,
Sensor device, connectivity Wi-Fi,
data processing ada,
controller.
okay, and then user interface.
User interface ada dekat phone.
Okay, alright.
This is IoT circuit using not MCU ESP32 and programmable logic controller CP1E. This is a controller that have produced. All the sensor will be installed at the generator unit. This is a controller. This is a communication module. This is a installation process, labeling and termination of the cable to carry out as typical wiring detail drawing. For termination, strip the cable with wire stripper, then screw the cable into terminal strip as per typical wiring detail diagram. This is a C++ programming flowchart. This is not MCU ESP32 programming. This is a continue. Proximity sensor. This is a proximity sensor. Low oil pressure sensor. Water temperature sensor. This is a battery voltage sensor. This is a Node-RED dashboard diagram. This is a user interface. User interface to start or stop the generator unit. Okay, we have a on button, we have a off button. Also, we have a test for temperature, test for pressure, test for battery voltage, and test for speed of the generator. Okay, this is a graph output from the reading, sensor reading.
Dia display dekat phone.
Handphone, dekat laptop pun boleh juga.
Okay.
Using Node-RED punya platform lah.
Not red. Macam software ada sah. Not red lah tu.
Okay, this is a Node-RED dashboard.
Mhm.
Okay, we have a volt. We have a speed. We have a temperature, and we have a oil pressure.
So okay.
This is a notification.
Mhm.
Sensors will send a notification to the smartphone. Then we can monitor the notification via smartphone. Okay, this is engine temperature data for 1 hour. I have collect the data.
Okay, Zul bagi center. Ni
Center
Excel
mana?
kan? Kau bagi center, bagi tengah-tengah semua data ni.
Oh, okay. Okay, baik. Bagi center, okay, baik.
Kolom tu center kan?
Mm-mm.
Data semua.
Semua.
Hmm.
Okay, this is a graph.
Okay, tengok dia punya graph. Kenapa
Graph
rendah, kenapa tinggi? Malam Engine temperature.
engine temperature.
Maknanya 31.62 apa ni? Unit apa ni?
Degree
Graph
C.
ada axis label.
Degree C saya.
Ha?
Degree C ni dia
Y axis tu apa? Temperature Celsius.
yes, degree C.
Tulis temperature degree Celsius.
Degree Celsius.
X axis adalah day.
D.
Date of the day.
D.
Boleh komen sikit tak? Apa yang finding yang kita dapat ni?
Sebab dia punya sensor ni dia hantar signal every 1 minute.
Oh. Jadi
1 minit. So kalau dia tak ada perubahan, mostly graph tu dia punya value tu akan sama.
1/1 apa benda tu?
Ini dia referring to ni apa? Graph punya template.
Tak. 1/1/1900 tu apa?
Time.
Pukul 7. Itu dia punya data dia tu average
Average.
Berapa data ada? Every 1 minute.
Every 1 minute.
Okay. Hari tu kita bincang every 1 minute bukan every 1 hour.
Itulah saya projek tu, sensor tu dia akan hantar sensor
every 1 minute.
Akan hantar data every 1 minute. Jadi
Artinya
terlampau banyak kan?
Banyaklah.
Sangat banyak. Kalau nak buat 1 jam dia akan jadi 60 data. So graph tu dia akan ada 60. Kalau buah chart ni 60 buah chart lah.
Kenapa dia rendah?
Apa bro?
Kenapa dia rendah? 31.62. Tak jauh beza. 31.62 yang
ya, 31.62 ni dia apa, enjin sejuk lah ni.
Enjin sejuk. 31.670.
Mana?
Sebelah dia.
3 sini.
2/1.
Sini. Ini naik sikit lah.
Naik sikit. Tak banyak pun beza.
Tu lah different ni tak banyak.
3168, 3162 tak jauh beza bang.
Yalah. Itu yang saya duk fikir macam mana nak buat graf ni, sama ada dia per day ataupun dia dalam tempoh 1 jam kan. 1 jam 60 minit tu graf dia
I think 1 jam kot.
1 jam
1 jam.
Ya, boleh saya kena come out graf baru lah.
Graf baru lah 1 jam. Macam dia tak jauh beza di antara tu. Okay, next. Nanti hari Sabtu present balik.
Okay, baik. So this is a battery voltage data. Okay, so video.
Yang lain pressure tak ada.
Tadi dah tunjuk tadi.
Oh, dah tunjuk Tengok. Tak perasan pula.
Ni apa? Pressure. Oh, pressure belum.
Belum lagi. Baru tunjuk
Hmm.
satu ni. Temperature,
Sebab dia
pressure.
mostly dia lebih kurang macam ni, Prof.
Jadi dia punya tu just nak tunjuk dia boleh display, maknanya IoT
Dia,
boleh apply lah
dia
pada
boleh come
sistem
out
ni.
data daripada sensor.
Itu
Cuma tu
dia
lah
lah.
masa tu lah 1 minit dengan 1 hari tu kan.
1 jam,
Nak
1
buat.
jam. 1 jam.
Okay.
Satu hari 24 jam.
1 hari 1 jam Okay.
1 jam. Video.
Okay, video dulu
Namanya?
Kejap. Nampak tak?
Okay.
Okay, saya on. Okay, so this system will using smartphone. The diesel generator can start using smartphone.
Okay. Tak ada bunyi. Warm up. Bila warm up ni ada data dia tak?
Apa dia?
Bila warm up ni ada data dia tak?
Kena ada.
Yang dia tidur satu, yang warm up satu, yang dia on. Data yang awak tunjuk tu dia tidur Maknanya dia off. Graf yang awak tunjuk tu dia off kan? Yang on punya ada tak? Data yang on.
Data yang on. Ada Prof.
Ada tak tunjuk
Kalau nak saya kena buka.
Okey. So hari Sabtu nanti tunjuk lah.
Masukkan dalam video ni.
Tak, masuk dalam slide.
Data suatu.
Satu ialah waktu dia off genset.
Oh, okay.
On genset ada data lain. Jadi ada nampak lah perubahan dia tu.
Betul.
Kita nak tengok perubahan. Macam si Sobri tu kan. Sebelum dan selepas ada penjimatan. Walaupun data dia sebulan aja.
Perubahan yang drastik yang apa?
Nampaklah temperature bila genset tu dia on, mesti temperature naik kan?
Betul. Tapi dia akan take time sikit lah. Bagi lama sikit yang hidup.
Kena ada data tu untuk tunjuk presentation. Jadi awak nak tunjuk temperature dengan pressure ke? Nak tunjuk
boleh display 4-4 tu lah.
Bolehlah display 4-4. Nanti hari Sabtu tunjuk. Ada masa lagi. Okey. Saya banyak perubahan, banyak progress. Saya komen-komen banyak yang awak dah apa nama tu carry out, dah take note. Cuma result tu boleh di-enhancekan lagi. Saya nampak ada findings, ada significant. Jadi nak turun bila?
Turun mana?
Turun JB bila?
Hari Sabtu malam.
Sabtu malam. Sobri?
Kami semua sama.
Satu bas.
Sama Prof. Sekali.
Jadi hari Ahad tu boleh present lagi face to face.
Boleh.
Hari Ahad tu Sabtu saya nak tengok lagi. Dan Ahad present lagi. Banyak kali tengok supaya dia. Cuma awak punya masa nak bercakap tu dia 10 minit aja.
Ya.
Banyak ada yang tu laju lah. Yang penting slow. Yang dah present masa FYP1 tu laju.
Nanti nak present face to face dekat mana, Prof?
Ha?
Nak present face to face kat mana?
Dekat office saya.
Okey, ayah kan. Okey.
Dekat office saya Had. Sekejap, presentnya hari Senin. Pergi tengok tempat dulu kat mana.
Betul.
Okay.
Semua barang saya ni kalau bawa nanti macam mana nak apa nak demo real demo ni, Prof?
Barang pakai video. Awak kena ada video.
Ha.
Demo awak adalah video sebab genset tu mana boleh bawa. Itu hak milik kerajaan.
Betul.
Bawa video. Video tu penting. Ambillah video. Beberapa video. Okay.
Okay, baik. Terima kasih, Prof.
Okay,
Prof.
you.
Ya, Prof. Good
Okay.
morning, Prof.
Yeah.
Good morning, rakan-rakan.
Okay.
So, tajuk saya untuk PSM2 tu Auto Navigation Train System.
Tan, suruh budak diam-diam.
Yang busy sangat. Okay, so next, this is my context of activity. For part 1 is introduction, part 2 is problem statement, part 3 objective, part 4 project scope and limitation, part 5 literature review, part 6 methodology, 7 expected result, final is part 8 conclusion and then list of reference. For introduction, my train technology is the most popular transportation since the year of 1822. So the train is also known as a transferring passenger and goods. And then there are advantage for railway transport, which is less affected by wet weather conditions. Okay, but there is some problem regarding the collision, accidents, and derailment. So the purpose of my project is to, this is the example for Malaysia, the latest incidents happened in Malaysia.
Don't mix up between problem statement and motivation. It's two different things.
Oh, okay.
Problem statement lain, motivation lain. I think
So
this one is more towards macam mana cakap? Motivation lah kot. Sebab banyak accident. Then we need a safety issue there. Itu motivation.
Okay. Okay, baik.
Problem statement, apa yang awak nak buat?
Okay, baik, Prof.
Okay.
So here is the purpose I'm doing this project, because this is the case study for our latest case in Malaysia. Okay. The next is the objective. So I will put the photoelectric sensor to detect obstacle and proximity sensor to detect the matter on the track and DC motor to make the train move forward. Then Omega 32A as our subject in UTM space. So I will use it for my microcontroller as an element to control the input-output interface. Then the final, I will integrate between the software and the hardware. Okay. So here is the scope and limitation for my project. Omega 32 photoelectric sensor multi-sim is a software to simulate the circuit, proximity sensor, DC motor, and H bridge. So project limitation. Here is I will use the photoelectric sensor brand Honeywell with the digital measurement of 4 cm to until 20 cm detection distance. Then the maximum distance sensing for proximity sensor is to detect the metal between 0 mm until 5 mm. Then here is the DC motor to make the train move forward by using 12-volt operating voltage, then 8-bit Omega 32A microcontroller. So here is my literature review, 6 of my literature review. Okay. So methodology. Electric circuit designed by using PCB fabricate for sensor and motor. Then I will write the programming and burn to Omega 32 and interface between the hardware and software and test the stability of the train. Next is the flowchart of my project. So if anything detected by the photoelectric sensor, either one of the sensor is detected, then it will stop moving. If not, will go to detect the metal track. Then if no, go to metal track. If no, also will stop moving. If yes, they will move the wheel. DC motor will operate. So here is the component I'm using. This is the photoelectric sensor. Then voltage regulator 7805 to ensure the voltage output from the sensor is 5 volt to avoid burnout at mega 32. Then proximity sensor to detect the metal track. And then H bridge and DC motor. So here is my methodology of my project. Okay, so regarding the IoT architecture, here is I will using ESP32 as a wireless, can say Arduino device module to control the Blink server, and then to mobile dashboard and dashboard to monitor my GPS and speed of the train. So here GUI NEO6MG2 is the GPS device. So here is the architecture for the IoT. Okay, this is the ESP32. Here is the GPS to detect the satellite. Then Arduino IDE to program ESP32 and connect to internet, and we can view the speed and the GPS via the web dashboard and mobile dashboard. So here is the programming. So from here we can see, here is my code. Here is the after detection of the GPS. Here is the mobile dashboard. Ini adalah web dashboard. Here is the web dashboard. Here is the mobile dashboard.
Okay.
Okay. So this is the mobile, this is the web dashboard. So I will comparing the simultaneously speed operation. So when 7 km/h, here's 9 km/h. Then it will work simultaneously within the mobile and the web dashboard. Okay. So for the next expected outcome, when the photoelectric sensor is detected.
There is no expected outcome. It's the results.
Oh, result.
Ini FYP1 mah. Results. No, take note Zul dengan Sobri bukan expected lagi. Kenyataan, results. Itu expected sudah lepas mah.
Okay, so when the obstacle photoelectric sensor is detect any obstacle in front of the train will stop moving. So I will using both two photoelectric sensor. So either one photoelectric sensor is detect obstacle, the train will stop moving. So when left proximity sensor fail to detect the metal on the track rail, this will stop the right DC motor. So in order to move the train aligned to the track. So later I will show the video end of the slide. Okay. So here is the simulation or simulation of my train. Oh, I have to put. Okay, so here's a busy. So the train will stop moving when detect the obstacle. Here is the train if fail to detect metal. Sorry. So this is just the animation. So later I will show the project real product lah. So this is the fail to detect the metal track. So this is my photoelectric sensor been using to my project. Here is the circuit. So here is the LM7805 voltage regulator to make the output voltage 5 volt as an input for microcontroller. So here is the proximity sensor I was using for my project also. Then this is the circuit for proximity sensor. Then same also got voltage regulator 7805.
What is the function of D1 diode?
Diode to stabilize the circuit, to make the circuit stability.
Stability.
Hmm.
And another diode on the left, what is the function?
Here, LED. LED.
For
So
what?
LED, when they detect metal or obstacle, the LED will light up.
And the function of voltage regulator?
To cut down the voltage to ensure output voltage is 5 volts, so won't burn out our microcontroller.
Bukan
Because
cut
our
down,
microcontroller
bukan cut down, step down.
step down.
Kalau cut down sudah tak jalan lah.
Step down because our microcontroller accepted input voltage around 5.5 volt. So if exceed more than 5.5 volt, will burn out our Mega 32 chip.
Put ground symbol below the circuit, ground.
Oh, okay. Yeah.
Okay.
Okay. So here is my color code for my sensor, photoelectric sensor and proximity sensor.
COLOUR.
Oh,
Okay. Then VCC, subscript CC.
subscript CC.
CC itu subscript.
Apa maksud bro? Macam mana?
Itu CC turun bawah sikit.
Oh,
Subscript turun bawah.
turun bawah. Tapi I ini dalam table lah. Nanti I akan turun bawah dalam kolom.
Tulis balik lah, tulis balik.
Okay. So ini sensor to Mega 32A port. So ini port dia yang akan connect pergi kita punya sensor lah. Okay. So here is the output voltage for my sensor. So 5 volt. 5 volt when detecting the obstacle or metal. Without detecting is 0 volts. So this will as a Mega 32 as a binary 1 or 0 detection or not detection to let microcontroller know the output when to move the DC motor. Okay, so I will use the Protos 8 to design my circuit. Here's my circuit diagram that I will fabricate to my PCB board. Okay. So here I'm designing the PCB board without overlapping each other to make the circuit be more tidy up without any jumpering, anything. So here is my train.
Okay.
So here is my wheel. This is the proximity sensor, photoelectric sensor, the blue color one.
Okay.
Then the DC motor.
Okay.
Then here is the switch, my 9 volt power supply. Okay. So here is the IoT, here is the software that I use to burn the Mega 32A programming. Okay. Okay, here is the programming that I write by my own without any market cannot find this one.
Okay, flowchart dia apa? Flowchart dia?
Flowchart dia sini.
Oh, flowchart dulu baru teks.
Oh.
Okay. Flowchart dulu baru masuk dia punya coding.
Okay.
Tengok.
So flowchart when detection of the proximity sensor left right, then we'll move the DC motor left right to align the train to the track lah. Basically it's like that. No? So I will describe in my programming. So this is my programming to ensure the port. This to declare my port number. Then port A as a 0 is as a input. Then 1 is as an output. Then yeah, this I'm using the if else statement. Okay. So next, here's the
Ini
conclusion.
yang kita bincang hari tu ada state dia punya position tak?
Position ah. Macam mana?
Kan hari, hari tu kan kita ada bincang.
Hmm.
Masa anak you dekat hospital tu.
Oh.
I ada komen. Satu adalah obstacle, itu dah buat. Satu lagi metal, satu lagi adalah metal putus. Yang ketiga, improvement yang kita kena buat apa? Position of the train bila dia pusing dekat situ.
Position of the train bila dia pusing di corner.
Location dia bila dia pusing. Itu.
Location GPS. Oh, GPS ada dia di.
Tak masuk
di video sini.
Gila, video tu memang tak ada.
Di sini lah, Prof. Yang location ni.
Oh, ada?
Ada. Ini latitude and longitude.
Ada ditunjuk ke?
Dalam saya punya ini ke?
Ada tunjuk?
Ini longitude and latitude.
Okay.
But then our web. Tapi
dia punya track tu dia tunjuk tak latitude dengan longitude?
Oh, track tak ada. I akan build my IoT di train. So, I punya train jalan sampai mana, dia akan show latitude and longitude of the position, location of the train.
Yang itu ada masuk tak dalam objektif?
Objektif
tak masuk katanya.
Tak masuk lagi. Nanti I masukkan dalam sini.
Tulisannya nombor 1. Obstacle, proximity sensor and train location. I think tak payahlah cakap sensor tu, just to detect obstacle, metal and train location. Jadi yang sensor-sensor tu nanti dalam metodologi. Janganlah semua nak sumbat masuk. Dia objektif ni kena general.
Okay.
Jadi awak ada 3 benda lah. Betul tak?
Betul.
Jadi yang video tu dia tak ada tunjuk location video yang simulation tu.
Video yang ini.
Yang simulation tu bukan yang yang gambar kartun tu.
Animation tu.
Gambar kartun.
Mana pi?
Tak.
Nak masuk juga.
Nombor 2 dengan nombor 3 location.
Location.
Dia gerak tu dia tunjuk lah dia punya latitude dan longitude.
Okay, baik.
GPS memang tunjuk latitude dengan longitude.
GPS memang longitude, latitude. Tapi dia punya web dashboard dia kurang sikit lah. Dia 1 decimal saja.
Speed, okay. Dia punya speed maksimum berapa?
I letak 100 sebab I masa buat testing
100 km. Betul.
Just simulation saja. Sebab masa I buat testing I letak 100 lah.
Yang sebenarnya yang train yang awak prototype tu dah ada video dah tak?
Ada.
Cuba tengok.
Okay.
Itu panel dia suka tengok benda tu. Video lain lah.
So it's my train.
Apa pasal slow sangat train ni? Dia macam itu je.
Ya.
Macam kereta lah. Dia tak ada ni. Dia tak ada belakang dia tu tak tarik.
Tak tarik.
So tu metal. Yang dia punya tu metal lah. Jangan pakai tangan mah. Mau obstacle betul mah.
Nanti I bagian.
Apa pakai tangan. Dia betul-betul lah. Dia punya obstacle tu. Kayu ke apa tu.
So inilah masa dia buat cornering, dia akan detect metal then move the right DC motor.
Ada student pakai black tape. Itu pakai apa? Kalau black tape pakai apa?
reflection, dia tak ada reflection dan back
Dia ada pakai ni dia,
infrared.
putus.
Nak putus ke? Tak buat putus.
Buatlah putus.
Oh.
Nampak? I say man. Kalau tunjuk putus, kita tunjuk putus. Tak putus, tunjuk tak putus.
Okay.
Okay. Tunjuk yang obstacle, dia tengah pusing tu.
Habislah.
Tunjuk yang obstacle, jangan pakai tangan
Okay. Bye-bye.
Lepas tu yang putus punya.
Okay.
Dia tengah pusing 75%, dia putuskan. Tengok dia punya respon macam mana. Dan location macam mana? Dia tunjuk kat mana?
Location dia akan tunjuk dekat mobile dengan dashboard.
Tunjukkanlah dia punya video location tu berubah. Itu benda tu ialah result awak tu.
Baik. Macam ni kan. Macam ini kan.
Tunjuk video, kemudian demo sekali lah. Sebab punya barang kira macam orang kata tu apa? Kalau kecil kita panggil apa
tiny.
Bukan tiny. Boleh bawa dari Penang ke Skudai lah. Benda tu macam compatible lah kan. Maknanya bukan compatible. Apa
Portable
lah. Macam si Zul punya tu tak portable sebab dia genset. Dia sudah screw dekat itu earth. Dekat cement lab tu dia sudah screw situ Di Zul kalau mau bawa itu benda, dia kena sewa lori tu. Dia kena bayar. Itu lori pergi balik tu. In fact, kalau dia kena bayar itu lodging, driver sekali, bukan angkat semua dia kena bayar, allowance makan, allowance tidur semua kan. Tol semua dia kena bayar mah. Tapi Zul punya video tu kena betul-betul canggih lah. Maknanya betul-betul minta orang yang pandai buat video lah, yang TikToknya, kaki TikTok yang buat video. Okay. Ada orang datang? Okay. I see you insyaAllah next Saturday pukul 10.
Okay, bye-bye, Prof.
Kira yang
Okay, Prof.
Kira yang less error lah. Sikit-sikit error lah. Banyak dah saya betulkan ni
Prof, besok nak hantar slide ke?
Awak email slide lah. Email pada saya slide.
Okay, bye-bye, Prof.
Email slide yang hari ni punya.
Okay, bye, Prof.
Kemudian hari Sabtu saya nak tengok yang lain sikit lah, yang ada komen saya. Dan tadi saya ada komen kan? Okay. Alright.
Okay, thank you, Prof.
Okay, thank you, Prof.